welcome to the maths lesson. So today we're going to look at some financial maths or finance and growth. In specific, we're going to look at compound growth. So we're going to explore what exactly does it mean and what are the big ideas, what are the concepts we're going to look at. But before that, let's just go back quickly and just recap on what we've done in our previous lesson. So we've looked at our big idea, which was growth, and then under growth we looked at what we call a pattern, the graphs and equations, and then the context played a very big role because we looked at society and then we looked at finance as well. And then what I wanted you guys to think about was, if we are describing growth using maths, we talk about whether there is a pattern, and we talk about whether we can develop a model to predict some growth. And then under patterns, remember there were three types: our simple, compound, and random. And then data, we had the concept of equations and graphs, so we can explore data using equations or explore data using graphs. Now with simple, remember our example of the exercise, which was the steps walked. The person decided to walk 5 steps on the first day, which was actually day 8 in this instance, Monday. On day 9, they increased by 100 and 100 and 100 like that as the days continued. So you saw that this had a constant growth of 100. So that's the simple growth. And then what we then looked at, our keywords, where we measure the change that is a constant, which we just saw in the previous table. And then lastly would be the arithmetic pattern that we kind of spoke about. And then the last keyword was the gradient, which is the steepness of a slope. Now if we look at the concept of a gradient, the line will look something like this, which would then be our graph. And the graph will normally have a gradient, and it will also have an equation, which would be a model in this instance. The graph itself is also a model. That's one of the things that you need to know as well. Now, patterns in the context of finance, our key concepts there, or keywords, were savings. So remember, this was for a short period of time. Investment was for a very long period of time. Principal amount was the initial amount you start with. Accumulated amount would be the amount you get over a period of time. And then we have the interest, and lastly our interest rate. Now today we're actually going to look at some compound patterns. And then before anything, let's just look at some graphs and try and talk about this. Now here, remember, how we describe a growth using maths is we'll talk about whether there is a pattern and whether we can develop a model. Now you will see that with compound, it means, one, the change is there, growth is there, but it is not a constant growth like we've seen with our previous lesson. So that's what we are going to try and explore in great detail, and actually even get to doing some calculations with that. Now, if we look at some graphs, this is a graph that shows the spread of COVID-19 virus in India. Now, this was between the months March 2020 and November 2020. Now, if you look at this, between March 2020, or between the 0 there and roughly June here, because that will be June there. So between that and June here, you can see that it looks like there is no growth or there is no change whatsoever. But, so meaning the small change over a long time. But if you continue with this, you will see that from June up until roughly our August there, which is like 2 months, there was very rapid growth, which got us to 2 million number of cases. And then from the August until September there, you can see that it's now a very big jump as well, which goes to a 4 million, but now it's taking 1 month instead of 2 months. and then continuing like that. So you can see that now for us to have a big change, the time is a bit smaller. So what does this mean? It means when you talk about growth under compound patterns, we are saying the longer the time, your growth will be a bit small. But over a short period of time, then our growth, as you see here, is quite rapid. So that's what we're really going to be talking about. Now, if we look at compound growth, we can see that our change is not constant. The rate of change is also not constant. And then the time to double becomes smaller, right? So let's quickly just go back to that table. So you can see now here that from this point to that point, this went to 2 million, right? For it to double, it must get to 4 million. But 4 million, you can see roughly that it took actually a month to double, when it took maybe 2 months to get to 2 million. And then from September, you can see up until there, this is really not a month. It could be half a month. And you see it takes half a month for it to double as well. And then roughly up until you get there, you can see that it takes 1 more month to then double up as well. So what does this mean? Our rate of change through time, you can see that it's not constant. Also, our change is not constant, meaning the number of cases that I had here and the number of cases I have here, the difference between the two will not be the same as the number of cases that I will have at that point, which will still not be the same as the number of cases that I will have at that point. Also, not the same as the number of cases I will have at that point. And then lastly, not the same as the number of cases that I will have at that point. So this shows us that with the compound growth, we do not necessarily have a constant growth that we are talking about, constant in terms of change, and then we are also do not have a constant rate of change going forward with this. So the big idea here, you can see under compound growth, the change is not constant, our rate of change is also not constant, and then the time to double becomes smaller. So what does this mean? It means time is of the great importance when dealing with some compound growth. But we'll look at this further as we are continuing. Now, you can see that with all of this that we've spoken about, the main big idea here is with compound growth, we don't have a constant change, we don't have a constant rate of change, and the time that it takes for the change to double up is becoming smaller and smaller as you are progressing with the time that we are having. So that's all that I have for now. We're gonna go quickly to an ad break and I'll be back with some more. Stay tuned. Hi guys, welcome back to the show. So we are still busy with our compound growth. Firstly, we looked at some revision that we did of the previous lesson, and also we then went on to look at compound growth using graphs. Now we're gonna explore compound growth now using data. Data in a sense of what happens when I have the number of maybe people that went to a stadium this month, and the number of people that went to the stadium the next month, and the number of people that went to the stadium the other month. What is happening? What will be the growth there? Is it constant? Remember, we said it's not going to be. Why? Because we are dealing with compound growth. And then also, is the rate of change constant? No, because why? We are still dealing with compound interest. And stadiums are also a typical example of what you're talking about, because you know that it depends on what is playing there. Hence, people will attend maybe in great numbers. At times, they will not attend in great numbers. And also, when exactly is the game playing? Because maybe some people might not have mode of transport to get there if it's too late, or if maybe they will not be able to go there because they're at work if it's during the day and all. So those are just the things that you need to be considering when talking about this concept. But now let's just look in specific what it means to have compound growth when looking at data. Now, we said we are still looking at compound growth and we're looking at data. Now, week 1, we are looking at, or we are comparing the number of spores, right? The number of spores would be bacteria maybe that we are talking about here. With number of spores in week 1, you can see that it was 5,000. In week 2, it was 5,250. So what does this mean? It means if it was to be a constant growth for the 3rd week, it must now be 5,500 because it must increase with 250. That's if it will be a constant growth. But if not, then we need to talk about something else. So let's actually check whether it is a constant or not constant. Now you can see that with week 3, it goes to 5,513. Roughly, it's closer to it being 5.5, but it is actually more by 13 there, or 13 spores. And then you go to week 4. With week 4, if it was a constant growth, it was supposed to be 5,750, but you can see that that's not what we are dealing with there. Instead, this is actually more by what? 38. And then with the last week, which is week 5, you can see that the number of spores there was actually supposed to be 6,000 if it was a constant growth, but that's definitely not what we are dealing with. This is more by 78. So you can see that the growth is not constant, number 1. The change is not constant. The rate of change is also not constant. And time, remember we said, is of a very important factor here. But let's just plot this on a graph and see exactly how does it look. On a graph, the number of spores growing in 6 weeks. You can see that with week 1, I had 5,000. With week 2, I have 5,250. With week 3, I had 5,513. With week 4, I had 5,788. And then with week 5, I had 6,000, and I think it was 6,078, right? It was 6,078 that we're dealing with here. So those are the values that we see. So you can see that our growth is not necessarily a constant growth that we're dealing with. But let's just try and take this further now. Now let's say if we are talking about 10 weeks now, 20 weeks, 30 weeks, 40 weeks, 50 weeks. You can see that when it was 10 weeks, our number of spores that we have is 7,757. The time it takes to double, which means from, if you double the time, if you go to 20 weeks, it's not necessarily double what I have there, right? Because it's 12,000, so it's slightly less than double the number of spores that I had initially. If you go to 30, you can see now it's more than double that, right? So it actually took until 30 weeks to double from 10 weeks. 40 weeks, you can see this is a very big number. And then 50 weeks, it's also a very big number. And if I plot this, then you can see that my growth now will look something of this nature. So this would mean that my growth is an exponential growth, right? When you talk about exponential growth, guys, remember that we are talking about a geometric sequence that you guys are familiar with here. So that's what we are actually looking at when we talk about an exponential growth. Now, let's just exaggerate it as well and say, if now from 50 to 250, you look at what is happening here. When you get to 250, now you are closer to 1 billion now. So you see, this is quite a lot of spores that we are dealing with. And if you look at between 50 and 100. That's double the time, right? But when you look at the number of spores, it's way more than double whatever that I started with at 50. So this goes back to that concept that we started with, to say the time it takes for us to have a smaller change is longer, but the time it takes for us to have a bigger change, it's actually smaller. And this, by the way, is the power of compound interest and compound growth, which we'll just look at in a short while. This is the power of what it means to deal with compound growth and what it means to deal with compound interest if it was maybe an investment or a savings account of that nature. So stay tuned. It's really quite a very big idea that we're dealing with. Now, if you look at the graph for this one, you can see that roughly here, it shows us to be having quite a very minimal change here, like from no growth at all, until you get to roughly here by 175 weeks. And then you get to 200 weeks, you can see it's half of that, and then it gets there, it's like that amount that I have there. And that amount will actually double in a very short period of time, because this is the time it takes for it to now double, as you can see, from 20 to 40 there. And then also, for it to double, it's now a very shorter time compared to the previous one, right? So you can see it doubles in that region there. And also, as you are progressing, you can see it doubles there as well. So it takes very also minimal time for it to double, and as you continue like that. So what does this mean? It goes back to the very same concept I'm just explaining now. As you are starting, the longer the time, it will make it look like it is not growing, right? But as you are progressing, you'll see that now the level of growth and the rate of growth is quite rapid in a very short period of time. Hence, time is important. What do I mean when I say time? Let's say maybe we're talking about an investment. If you have an investment, it would be a good idea to leave your investment for a very long time, provided that it's a realistically long time. So you can't say you're going to leave it for 100 years. Honestly, then you are not really being that realistic. But if you were to say you want to invest and you want to invest for 5 years, it might be a good idea to go and invest maybe for 10 years instead of 5 years. Because maybe for the first 5 years, your growth might not be that rapid. But for the last 5 years, it might be a very rapid growth in a very short while. So that's what we are actually looking at here, that time plays a big role in you investing or in you having growth that will take place over time. Now, if we were to calculate the rate of compound growth now that we're dealing with. So in week 1, remember our first table, we had 5,000. In week 2, we had 5,250. So to calculate the rate here, remember that we are not adding, right? So from there to there, yes, you can add. But from there to there, you can see that what you are adding is not the same anymore. So I can't add. Instead, it's a geometric pattern. So let's quickly just look at how I would calculate this, right? So I will just write down my values here. It's 5,000, and it will be 5,250, and then it will be 5,530, right? And then what you will then do is you will look at the common ratio as we normally do under our geometric pattern. But this is just us still trying to explore this. So this will be 5,250, and then you divide this by the 5,000 there. The answer you get here must roughly be the same as the answer you get if you divide these two last digits or last two numbers that I have here. So if I divide those two and I divide those two, I must roughly get the very same value that I need to get there. So that will be the case there. So 5 into that, you know it's going to be 1, comma, I'm left with 250. It does not go into 250, and then you will see that at the end you will be left with a percentage, maybe roughly around 0.5% that we are dealing with. So this will be how you would then find the actual growth, a rate of growth when it comes to this. And also remember, our rate of growth talks to the gradient, right? So you will just need to do gradient of this. But if we were to look at it from a perspective of gradient, it means that I would say that minus that over that minus that. But you can already see 2 minus 1 is actually just 1. Hence, when I get here, I don't really take that into consideration, right? So that's what you will be looking at in terms of your growth there. And if I was to look at that minus that divided by that minus that, it must give me roughly the same as that minus that divided by that minus that. But here it won't. Why? Because if that is what I would then need to get, it would mean I have the same gradient throughout. And the same gradient, what that would mean is my change is constant. So please think about this carefully. When I'm dealing with a simple growth, which is the previous lesson that we had, we know that in a simple growth, I have a constant change. Constant change meaning I can talk about gradient, right? But now I'm dealing with a compound growth. Compound growth, it's not the same throughout. As it is not the same throughout, that means I do not have a gradient that will be the same throughout, because gradient needs to be the same. I mean, also, if we quickly just go back to the table here, you can see that if I wanted to find what the gradient is, my gradient will be changing. Maybe there it will be the same, but when I get to that point, it will be a different gradient. So I can't really talk about gradient. Hence, when you talk about the concept of rate of change, that is not constant that we are dealing with, right? So it's not constant that we're dealing with. So that's the big idea here of compound growth. Compound growth depends greatly on the time of investment or of the growth that you're dealing with. So if you're trying to open an investment one day, make sure that it's quite for a very long time and not just for 2 months. Because remember, if you want to invest for a year, that's not really investing. That's you saving, because maybe you want to buy something at the end of the year or in 2 years' time. But when you want to invest, you want to take advantage of what compound growth is all about going forward. So that's all that I have there. So if I wanted to calculate that, this is how I would then calculate it. So our compound growth, the big idea here is it's an exponential growth that we are dealing with, and then time determines the growth that we're dealing with. So I've just been emphasizing this a lot, that it is an exponential, so it takes on a form of an exponential graph like that, whereas the opposite of this was when we spoke about simple growth, and remember, simple growth was just like that, right? So these, you can see that they are opposites. Here, there's a constant change, which I will just call CC, but here, there is no constant change. And then also the last thing will be time determines the growth. So your time, or the time it takes that you are leaving something to grow, is of a very great importance in whatsoever that you are trying to grow. Guys, that's all from me for now. Let's just quickly go to an ad break and we'll be back with some more. Stay tuned. Hi guys, welcome back. So this is our last segment for the show. We are going to now specifically talk about compound growth in the context of finance. Remember, the first context we looked at was the society. We looked at if we were to graph it, what will happen. We looked at if we were to then have data, what will happen. Specifically now we're going to look at if I have data and I need to graph it, but under finance, and I also need to do some calculations also under finance. what exactly will happen there. So that's what we're really going to be looking at. So let's just jump right into it. So as you see here, remember that our big idea is still the concept of growth. We're looking at a pattern, specifically under society. Now we're looking at a pattern under finance there. Now, keywords for under finance would be the term or length of time. We normally represent this using the letter N, so please note that. We have the principal amount. The principal amount, we normally represent this using P. The accumulated amount, as you can see, the A there, we normally use A for this. The interest rate, which is normally either I or R, so we will say this would be I in this instance. And then the period of compounding. The period of compounding will be how often do you get your interest. So for example, let's say you've opened up an investment account, right? And you are saving 500 rands every month. How much you get as the interest rate, let's say, is 12% per annum. Per annum would mean we're talking about at the end of the year, right? How that interest is given to you each in that particular year is what compounding period means. Meaning, if I say to you, it's compounded monthly, it means I'm giving you 1% every month, because per annum it's supposed to be 12%. If I say it's compounded quarterly, it means every quarter, and we have 4 quarters in a year, so it means I must give you what? 3% every quarter or every 3 months, because at the end of the year it must amount to 12%. So that's what compounding period is about. It's about how often you get the interest within a duration of a year, and then multiply it by however many years that you are dealing with. Now, in terms of mathematics, now the formula or the equation for this will look something like this. A is equals to P, open bracket, 1 plus I, all to the exponent of n. Remember that our A will be the accumulated amount, so what you get after a certain period of time. Our P will be the principal amount, what you started with. So this will normally be if you are investing a lump sum for a long duration, right? So not you making monthly contributions. No, it's like saying I have 10,000, I just want to leave it there for 10 years. That's what the principal amount would be. And then I will be the interest that you normally get. So we normally divide I by 100, because we don't normally use percentages when we're dealing with calculators or with calculations. Now, our keywords would be the period of compounding, guys. Remember that I said it would either be per annum, which they normally show it as PA. This means you get interest every year. So if you have 10,000 and you are saving that 10,000 for 10 years, and they're giving you 12% per annum, it means you are getting 12% of the 10,000 at the end of every year, right? But you're going to get 12% of 10,000 for the first year. For the second year, you will get 12% of the 10,000 plus the 12% of the previous month. So that's what you will then use there. And then continuing like that. So it will be, I will just say A there, meaning for the previous month that we have. Semi-annually, semi would mean every 6 months, because it's semi-annual, right? Remember, semi means half. So half yearly. Every 6 months in a year, we give you 6%. If it was 12% per annum, compounded semi-annually, it would mean that the 12% is divided into 2 in a year. So I give you 6% at the end of June, I give you 6% at the end of December, but in a year you would have got 12%. And then we also have compounded quarterly, which I just explained now, but compounded quarterly, just remember as well, has to do with how many quarters I have in a year, and I'm getting interest every 3 months, right, in a year. So that means I have 4 quarters in a year. So at the end of March, at the end of June, at the end of September, and then December, like that. So that will be what we are talking about. And then lastly, I have compounded monthly. Monthly, as you can see, is quite straightforward. If it's 12%, I'm giving you 1% every month. But at the end of the year, when I add that, it must amount to 12%. Now, another concept that has to do with keywords would be our interest rate. There's nominal and effective interest rate. Né? So let me just quickly explain this. Then we'll do an example. Nominal interest rate will be what you are given for the whole year, right? So if they say to you, we're giving you 12% per annum, that's the nominal interest rate. But if I then say 12% per annum compounded monthly, the compounded monthly, if you take it into consideration, then it is now an effective interest rate, right? Which normally the effective interest rate is slightly more than the nominal interest rate. So the effective interest rate is what you get when you take into consideration the compounding period, and the nominal interest rate will be what you get just at the end of the year, right? So that's what we're talking about. So for example, if we're talking about that 12% of hours that I was just using now per annum, right? This means that this would be my nominal interest rate. But now, if I use 12% per annum compounded monthly now, compounded monthly, which I will say is that, it means I'm going to get 1%, right, each and every month. But remember that the growth under compound is normally an exponential growth. So meaning the 1% here will be for maybe, let's say, 10 rands. But the 1% here, it will not be for 10 rands only. It will be for 10 rands plus the 1% of the initial amount that you got. When you get here, it will be 1% of the past 2 months accumulated amount. It will be 1% of the past 3 months accumulated amount, 1% of the past 4 months accumulated amount. So what does that mean? It means at the end of the year, it will no longer be roughly 12%. It will be maybe 12.25% that you actually got. That's why if you go for an investment or anything like that, the big thing that you need to know, guys, is we deal with compound interest and nothing else. Because simple interest, as we saw with the simple growth, it's when you calculate for the original amount that you had in the bank. So if I say 10% of 100 rands, that's 10 rands, meaning every year I'm just adding 10 rands in your bank. But if it's compound interest, it's going to be 10% of what you have in the bank at that time. So for the first year, it will be 10% of 100 rand, which is 10 rands, right? So that's 100 rand plus 10 rand. For the second year, it's going to be 10% of 110 rands. Third year, 10% of whatever that I have at the end of two years. So that's why the compound interest or the compound growth is quite a very big concept and a very important concept if you want, or if you're looking at investing or saving money or anything like that. But let's look at an actual example and see how we can apply this. Now, Sibongile wants to invest 500 rands in a fixed deposit account for 5 years, right? Fixed deposit account, what does that mean? It means this is actually considered a lump sum, right? This is a lump sum. So this person only just takes the 500 rand, they throw it in the bank, and they leave it there. And they leave it for a duration of 5 years. The bank says, we are going to offer you, or to pay her rather, an interest rate of 12.5% per annum, right? Per annum is when we considering nominal interest rate. As soon as we then continue and say, okay, how is this compounded quarterly, then we're now talking about an effective interest rate. So what would this mean? If I want to know how much money she will have after 5 years, firstly, the big idea here will be, what is the interest that the person is getting from the bank? Number two, what was the principal amount? How much did they invest in the bank? Sibongile invested 500 rand in a fixed deposit account, right? How long was the investment for? It was for 5 years. How was it compounded? It was compounded quarterly. So meaning the 12.5% is actually going to be divided by 4, because I have 4 quarters in a year. So they will be getting a quarter of 12.5 at the end of every 3 months for the duration of their investment. But at the end of the year, it must all amount to 12.5. I will always emphasize, at the end of the year, please don't make the mistake of thinking that 12.5 compounded quarterly means the person is getting 12.5 every quarter. No. The 12.5 is what they get at the end of the year. But compounded quarterly means they get a quarter of that every 3 months in that particular duration. When you add it, it must amount to the 12.5%. Now, if we just maybe look at the calculations for this, right? So it will be roughly, I have 12.5, and I will divide this by 4, which will then give me roughly that amount that I have there, right? So, and you know that this will roughly be 4, something, right? So that is what they will get every month. So they will be getting an amount, a percentage of 4, a certain decimal there, percent at the end of every 3 months for the duration of the investment that they have, which will be the 5 years. Because at the end, when I add it, it must actually give me, the 12.5%. So if I wanted to calculate this, my formula would be A, which is the accumulated amount, is equals to P, which is the principal amount, 1 plus I to the exponent of N. And then my P, remember, will be the 500, and this will be into 1 plus, remember we said interest, we don't use it as percent, but we use it as a decimal fraction, meaning it's going to be 0.125, but this is divided into 4 months, or rather 4 quarters, right? To the exponent of now 5 years, it means in every year. Now let's understand the duration of the investment. The duration is 5 years, but for the first year, think about this. How many times did this Sibongile get the interest? Sibongile got interest 4 times in the first year. They got interest 4 times in the second year. So in 2 years, they got interest how many times? 8 times now. In the third year, they got it 4 times. So after 3 years, they got it how many times? 12 times. Like that, like that. So what does this mean? The compounding period, you will then multiply it by the number of years, because in every year, they are getting the interest 4 times. So in 5 years, they actually got the interest 20 times. And that's how you will then find what the N is, which is the exponent there. And that's how you will then look at what is it that you will need to do. So it means instead of just saying 5 there, I will say 5 multiplied by 4. So in simple terms, I am saying to you, when you look at our compounding period, which maybe I will just call CP, we are saying that the I will be divided by the compounding period, right? And the N will be multiplied by the compounding period. So, for example, if it is compounded monthly, this would mean that the I will be divided by 12, and then the N will be multiplied by 12. What does this mean? If the person opened the investment and they left it for 3 years, in each year, they're getting interest 12 times. So in the 3 years, it would mean they actually got the interest 36 times. And then the I was divided by 12 because per annum, yes, they might be getting maybe 8%, but you will need to split that into 12 months by dividing it by 12. Hence, that's what the big idea here is. For the compounding period, you divide the I by the compounding period, you multiply the N by the compounding period. Now, to just do this calculation, this is what I will then have here. So, if I want to calculate this, it will be 500, and then I will open a bracket there. It will be 1 plus, remember 0,125, and this is divided by, or let me just use a, okay, 125 divided by 4 because it's compounded quarterly, and then this will be to the exponent of 5 multiplied by the 4, and this will give me that amount there. So that will be the total amount that Sibongile will have at the end of 5 years. So you can see that if maybe Sibongile was to leave this investment for roughly, let's say, 10 years, then it might be quite a larger amount of that as opposed to what this is. So maybe let's look at what is it that I mean there. So if maybe they left this for, let's say, 10 years, you see, now it's 1,700, right? It actually is slightly less than double that. But if they leave it now for maybe 15 years, you can see that it's 3,000. It's way more than double that, right? So you can really see that what is it that we are trying to talk about here, that the longer the period that you are saving your money, the more money you are actually going to get, or the more advantage you're going to take of the compounding period. Now, just to recap on what we just spoke about, our big idea was growth. We spoke about patterns, and then under society we spoke about that that walking exercise that we looked at, and then under the finance context we also looked at compounding periods, we looked at the interest. So a quick summary of this is compound growth would be an exponential growth. So exponential growth meaning it is not growing at the same rate, right? It is growing at an exponential level, right? So meaning every month, the amount that you get, if it's an investment, is actually way more than the amount you got in the previous month, right? I made an example with saving maybe 100 rands and you're getting 10% of that, which is 10 rands. In the second year, you're not gonna get 10 rands. You're gonna get more than 10 rands, because then 10% of 110 is slightly more than 10 rands. You see, so meaning every time you're getting a slightly higher amount, hence it's an exponential growth. The last point is that time is the biggest factor. I can't stress this enough. With compound period and compound growth, there is no way that time will not be in your advantage. Time is always the biggest advantage that you need to take when it comes to investing under a compound growth. And that's all that we needed to look at. So guys, from me to you, bye. I will see you next time.